Mr. Soy Sauce.
Oh, you can see my article.
Where are you going?
I'm just playing with my light.
Okay. I thought we were starting.
We are. This is starting. This is all starting now.
Starting now. Well, at some point when I scrolled by. Oh, we're live. We are live. So let's do a show, everybody, shall we? Want to talk about science? Let's talk about science. Starting in 3, 2. This is TWIS. This Week in Science, episode number 748, recorded on Wednesday, November 20th, 2019. The Science Awakens. Hey everyone, I'm Dr. Kiki, and tonight we will fill your head with half a brain, a disco clam, and bees. But first,
Disclaimer. The following program contains unclassified information of both government-funded and academically executed science from around the world. Subjects often range in scale, scope, energy, and even time. One moment, we may find ourselves in the backyard of a spring garden observing bees. In the next, deep below a glacier, contemplating the movement of water. Then, without warning, we might find ourselves walking amongst extinct beasts, or walking on the moon, or walking the fine line between what we think we know and what we find when we actually look. Minds afraid of traveling need no ticket to take this ride, as they may never reach their destination. Irreversible increases in intelligence have been incredulously implied. And, as always, it starts with agreeing to open your ear holes to the audio brainwaves of This Week in Science, coming up next.
I've got the kind of mind that can't get enough. I want to learn everything. I want to fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I want to know what's happening. What's happening? What's happening this week in science? What's happening? What's happening? What's happening this week in science?
Good science to you, Kiki and Blair.
and a good science to you too, Justin, Blair, and everyone out there. Welcome to another episode of This Week in Science. We're here. We got science for you. A lot of it too. Some really good stories that we spent time this week trying to figure out what would we want to talk about this week on TWIS. Well, we've got some really great ones that I can't wait to talk about my stories. I'm sure you can't wait to talk about your stories. And you listening, you want to be part of this conversation? Let's get started. I have stories about the Force, half brains, and broth. Broth. Yes.
That's stupid.
Is this Kiki's cooking corner?
That's right. Kiki's Cooking Corner.
Kiki.
Got some secret science recipes for you coming up in the second half of the show. What do you have for us, Justin?
I've got yeasty bees, intergalactic fireworks, galactic eyes, and why laughing gas is no laughing matter.
Blair, what's in the animal corner?
I too brought bees, but of the aquatic variety, let's say.
Aquatic bees.
Yes. I also brought
Never heard of 'em.
the
Just discovered on TWIS.
crazy groovy disco clams mentioned earlier. And then I have a couple of short stories about sick crows and bringing research papers into the 21st century.
Fantastic. I like 21st century research papers. It's going to be so great. It's going to be so great. Are we ready to jump into the show? Oh, yeah. We're ready. And as we do, if you're not yet subscribed to This Week in Science, you can find us all places that podcasts are found. Look for This Week in Science. You can also find us on YouTube. Are you watching on YouTube right now? Hi. You can find us on Facebook. Are you watching on Facebook right now? Hi. Or you can find us at our website, TWIS.org. TWIS.org is also where you can find the 2020 TWIS Blair's Animal Corner calendar. Get yours now. That's right. Get your order in so that you can have an awesome science calendar for 2020. And now, let's talk about, where did I put that half of my brain? Anyway. No, I am making light of a situation, but in reality, there have been many cases of people having to remove up to an entire hemisphere of their brain to treat very severe cases of epilepsy. And there have been cases where people have been born with only one half of a brain. And yet they go on to function at fairly equivalent levels to everybody else who's working with the whole brain. And the question has been for years, how are they doing this? How is it possible for someone who does not have an entire brain to understand speech, to be able to read and comprehend words, to be able to speak, to be able to have decent visual processing? How is somebody who only has half a brain, how do they do the things that we think take an entire brain? Well, nobody has really looked into it, at depth before. But now, reported in Cell Reports, a team has published a paper on their fMRI study looking at 6 adults who underwent hemispherectomies when they were kids. So as children, they had very severe epilepsy, and it led them, their families, to decide that the best course of action was to remove up to half of their brains.
Oh my, how do you make that? That's such a,
Yeah, your brain adjusts though, right? Like it
such
finds a
difficult
way.
call.
Which then I can't help but wonder, like, what's the other half of my brain for? If we could be doing the same with less, why aren't we?
Yeah, it makes you question a lot of the people with the full brain. Like,
Yeah, so these researchers, there have been, EEG studies and other MRI studies of people with limited brain capacity and what's going on. But this particular study I thought was very interesting because what it looked at was they looked at this. I'm going to share my screen for a second. Let's see if I can give people a little visual if you're here on the video right now. So they did fMRI studies looking at functional networks within the brain. So they used previous data on which areas of the brain seem to be connected when certain activities are taking place. And specifically data on when the brain has its downtime and isn't doing anything. And it's just going through, it's just, when your computer's just going through its normal processes and you're not doing anything to it. That's what they did. They just had people hang out and they took these fMRI images to see how they were connected together, how they worked together. And what they found is that areas of the brain that are connected in people who have not had these hemispherectomies, who have whole brains, that those functional networks are still intact in the hemispherectomy brains, but that they're much, much stronger. So the brains, in effect, Blair, you're right, they are doing more with the same amount. They are connecting more strongly. Areas related to memory processing, visual processing, language processing, all the things, proprioceptive, sensory processing, all of these networks that are involved in cognitive processing so that you can exist and function on a daily basis, they just wired more strongly together. And this is the first time that this has really been shown, but it's a pretty interesting interesting effect. There's definitely more to be delved into here as to how this occurs, why it occurs, and like the question is, why do we have such a big brain if we can do so much with less? So I think that's one of the most interesting questions that comes out of this. But it's a very limited number of individuals, 6 individuals, but I think it's a good first step in really understanding how people can go on to function with such with so much less brain material. And then I'm also very excited about the idea of brain plasticity, right? How much this means that our brains can change and modulate.
I have kind of 2 thoughts here. My first was kind of what we already started talking about, but evolutionarily, why on earth would you have such a large brain that requires so much energy and all this kind of stuff if you didn't need it? Evolutionarily, wouldn't it be better for brains to start to get smaller again? But my other thought is if we can wire a whole brain the way that this half brain is wired, does that increase capacity of full-size brains?
Well,
right, exactly.
We use this to
how much further can we go?
Push
Justin.
the boundaries of the full brain. Yeah. So first of all, I think you're absolutely right. I think evolutionarily, brains will become smaller for multiple different reasons. But this is also partly this connections they're saying are stronger. Are things closer? And if you don't have to go cross brain to access things, if it's all on that one side of the brain, is it just less distance to travel? It's sort of like being closer to, I don't know if it's still a thing, but you once upon a time, you could be closer to an internet hub of some sort. So that if you had this residence closer to where the signal is coming from, your internet was stronger than somebody who lived, even several blocks further away from it. Is it just that they're having to make all the connections on one side, and therefore it's closer, and that there's less brain latency?
Possibly. Yeah. Less brain latency, makes it more equivalent processing time with less neuronal material. I think the big question here also is whether or not there is a change to the brain density. I mean, there's obviously the connections are stronger. They're using functional magnetic resonance imaging, which is based on blood flow. So they're just saying these areas of the brain are getting more blood flow, which means by correlation that they're more active. And so they're active together at the same time, and their activity is correlated more strongly. So
maybe it's overclocking from keeping the computer.
Yeah.
Shubru in the chat room has an interesting idea of why our brains might be so large if you didn't need them. Maybe early humans ended up with brain injuries from dangerous conditions, and we have big brains for redundancy.
Also good. Redundancy or bubble wrap.
Yes. Yeah, it's why there are certain animals that have large litters. It's insurance. So maybe you have extra brain cells as insurance.
Possibly. Who knows? I move on to my next story. I want to get an update on a story we talked about a couple of years back. In 2016, we reported on some Hungarian physicists and also University of California, Irvine physicists who had been working on this proposed 5th fundamental force of nature. It is not confirmed yet, but there is some new data out. So the original experiments took place using radioactive beryllium molecules, and they saw electrons leaving the beryllium molecules in a particular pattern so that light was emitted, the electrons got emitted, there's light that gets emitted, and as the light was emitted, there's this angle that they see happening. And based on the laws of conservation of energy, the energy of the light producing the particles increases. So as the light gets more intense, the angle between particles that come from the light should decrease. But they kept finding this very specific angle separating electrons and positrons at 140 degrees. It was this very strange angle. And the researchers published in the archive, the Hungarian researchers, their paper that they ended up publishing in Scientific Reports didn't actually get a lot of coverage until the University of Irvine researchers got involved and wrote another paper, again, replicating the results and talking about them. And the physicists from Hungary, they originally were calling what they had found a dark photon. They didn't know what was going on. They were calling it a dark photon. And then the Irvine researchers got involved and they started calling it what did they call it? They called it let me look at my notes. They called it, yes, a protophobic boson. So they started saying that maybe this was another undiscovered boson, like the Higgs boson, a particle that has an effect that creates some kind of force that's not a part of the standard model. And being protophobic, that means that it pushes protons away and is more attracted to electrons and neutrons. And so in these experiments, they saw electrons and positrons getting shot out of these beryllium molecules. Update, the Hungarians have written a new paper, this time looking at helium atoms. And in their helium atom research, which is a preprint, it's not peer-reviewed yet. They've put it up on the archive if you want to take a look at it, but it's getting looked at by the scientific community. They did similar experiments using helium to what they had done with beryllium molecules previously. This time, instead of 140 degrees of separation of the particles that came out of this decaying helium atom, this time it was 115 degrees. So it doesn't quite match. And so that's a weird question. But again, they're finding this strange blip that was not predicted based on the standard model. This strange blip is occurring at a very high statistical frequency, very statistically significant. And these Hungarians and other researchers are still looking to see if this is not an artifact, but actually, yes, in fact, possibly real. And is there another fundamental force that we have never even thought of that could, because of the way it works, potentially be involved in explaining dark matter?
Go Hungarian physicist.
Yeah. Yeah, so this is, 2016 random fundamental force research, and here we are a couple of years later. They've got an update, a new experiment, new atoms. We still don't know. Nobody's confirming new fundamental force, but it is still open for investigation, which I think is always exciting.
So they were really thinking outside the box, or in this case, outside the nucleus.
So to speak. Yes, they were.
Speak.
Yeah. Yeah, but maybe there's another particle that we weren't expecting, which would be exciting because, like Justin, that would be something that is not within the standard model as we currently know it, which would be very
Well, it would still be within the standard model. But not as we. I mean, it wouldn't change. It would be adding it to it.
Right. It would be adding
it needs to be. It's one of those. And there's, we always like to think that we've got everything figured out. We're always at the point where
we have nothing figured out.
Done.
That's what this whole show is about.
Done.
Jon Snow, you know nothing.
All of physics. We understand how everything works now. And then these, something like this anomaly of this angle of the electrons coming from. So we can't explain this. Okay. So then comes the really, what I think is the exciting part, is in trying to figure out what could cause, how you could And in figuring out how you could answer that question, you end up with a sometimes many theoretical physics models that could address the issue, and they can't all be right. You have brilliant people coming up with answers to solve, but they can't all be right.
Nope.
And so then it's a matter of figuring out the experiment that can decipher the differences between those theoretical models and find the one that can stand on its own with that beyond theory. So these are all the inquiries into this are sometimes very difficult. Sometimes it takes us many decades to reach a definitive conclusion, or even to come up with all the theoretical physics that we even know where to begin our exploration. However, sometimes they come pretty quickly too. So we should keep an eye on this one. It may get resolved, another 3 years from now.
Yeah, I'm just gonna, every time I hear something related to this fifth force of nature, I'm just gonna, look into it and see if there's a new update that I can bring. Oh, and speaking of random things that people have found by digging places, researchers excavating ancient graves in South America at the Salango archaeological site in western Ecuador. This site dates back to approximately 100 BC. People of the local Guangala culture that's where they did their burials. There are many burial mounds there. Sarah Juengst at the University of North Carolina at Charlotte and her colleagues they dug up the burial mounds and found bodies, and two of them were babies whose heads had been encased in the skulls of other children.
I'm sorry.
Wait,
what?
Yes.
This is the grossest Russian doll you've ever heard of? Is that what this is?
Oh, God.
It's not a Russian nesting doll. It's a South American burial child. Yes, they determined that the babies were between about 6 to 9 months of age, and their heads, which during that age period is still fairly delicate, at burial had been encased in the skulls of kids aged somewhere between 4 and 12 years of age, and that they believe this external skull placement was for protection in the afterlife, that they were buried
as the helmet.
Protective helmets. Mm-hmm.
What?
Burial helmets. Yes. So this is a very interesting cultural practice that, very, very interesting. Like, there's just so many questions. So many questions as to what would lead to the practice, what beliefs would lead to the practice, and, exactly how it would have all worked.
Are we sure that they wore these only in death and they didn't wear them as helmets in life as well?
Have no idea.
Yeah, I'm just wondering. It would have been real creepy to look at, but it would have been pretty effective.
It would have been
a baby
effective.
Bonnet.
Yeah,
Here's
protective baby bonnet. Here, wear your skull, little Jimmy. Yeah. Anyway, this is This Week in Science. Hey, Justin, follow that one up.
Yeah, it's pretty crazy. This is researchers from Katholiek Universiteit Leuven, Belgian University, have found that the presence of yeasts on flowers can alter the chemical composition and nutritional value of the nectar. They also found that yeast can boost the health of colony fitness. So pollen and floral nectar contain yeasts on one flower. The types and amount of populations of yeast can vary pretty widely. These variations then lead to big nutritional value changes of the nectar itself. So the yeast get on there, They eat sugars. Then there's different amino acids that are present than there would have been without the yeast. So to find out whether the presence of the yeast and how it impacts the bees, a team led by Maria I. Pozzo from KU Leuven Biology Department added 5 different yeast species to nectars. They then investigated how the yeast affected the chemical composition of the nectar and how, in turn, it had an impact on the bees. What was sort of interesting, they also decided to take a look at whether or not the bees were more or less attracted to flowers that had this yeast. And they also looked at the development of the colonies post-consumption of yeasty flowers. They looked at things like the bee's size, weight, mortality rate, weight loss during hibernation, mating success, and resistance to infections. They did a pretty comprehensive long-term study in terms of how long you can study a bee. In addition to all of this was the attractiveness factor, which they actually was sort of interesting. They assumed, kind of hypothesized, that the bees would be less attracted to flowers that had a lot of yeast. Idea being the yeast is consuming the sugar, so there would be less sugar in this nectar available for the bees. The bees might have decided to bypass some of these a bit. Turns out bees didn't care. Bees actually, they weren't more attracted to these yeasty nectars, but they weren't at all put off by them. In fact, they would eat the nectar and yeast all together because the yeast basically at this point were sort of like sugary gumdrops to the bees. They basically have pre-concentrated nutrients and sugars in them, more so than the nectar itself. So they're probably just as tasty. So then they also went back, so they followed through and they looked at the health of the colonies, and they found that there were colonies that received yeast supplements that actually produced larger amount of worker bees, larger bees, and had more vigorous colonies. So it's just sort of pointing out, once again, that the microbiome is a big part of everything, not just within humans, but out there in nature as well. And so human activities, such as the use of a fungicide type thing to sort of purify our environment, could actually be really bad for bees, as this shows at least an additional health benefit to bees that have yeast in their diet.
That sounds like a net positive.
Net positive,
right?
And then also, yeah, and also this isn't it yeast and honey? Isn't that how you make like mead? Isn't it the old-fashioned alcoholic drink? Yeah,
right.
So maybe these are very happy bees.
Well, and yeast has, inherent sugar content. It also has protein in it. So there's some interesting benefits there. But yeast is also part of our microbiome, right? So there's something there too where it could just be part of a healthy hive could have yeast culture in it. Just inherently, right?
Yeah, this is this, like you said, goes into potentially how the fungicides are affecting bee colonies.
So bee colonies and other pollinators as well. So this is, they looked specifically at bees in this study, but the results show a broader impact of fungicide use and the health of any kind of a pollinator. Really, but as we look at bee colony collapse,
exactly,
understand the significance, the multi-billions of dollars of benefit to food production that the bees allow us to have for free. Yeah, these sorts of farming practices are still catching up. We've had agriculture now, I think, what is it? About 11,000 years? 11 to 14,000 years, maybe? Maybe it's further back. Maybe I'm an animal husband.
No, I think that's about right.
14,000, something like this. And we still have a lot to learn, apparently. But we're getting there. We're getting closer. But yeah,
I think it's the complexity of ecosystems and how do we really, how do we efficiently produce the food that we need without destroying the things that are important to the overall biome. How do we efficiently harness the power of something without going too far in some other direction somewhere else? And that I think those nuances are where the difficulty lies at this point.
Yeah, and we're about 70 years into following what was the 40s or 50s. I have this picture of first thing we needed to do to have a successful farm is destroy all the nature that was there beforehand.
Like, clean everything.
Yeah.
Disinfect.
Yeah. There's more. It's, of course, we now know this is like the most horrendous practice.
So strip it of all its nutrients and then go ahead and manufacture nutrients and reinsert them, will you?
Yeah. And make sure nature has other nature has no place in this whatsoever. It's very postmodern, primitive view on how to have a sustainable agriculture system. But we are catching up.
Yeah, I mean, I do hope that to support sustainably a growing population of people on the planet and onto other planets, that at one day in the future we can look back and go, oh, how quaint. Look at that period of time where they did that. Wasn't that silly? Now we know so much better. I mean, I really hope that we get there. But you know where we've gotten right now?
Where have we arrived?
Blair's Animal Corner.
Oh my gosh.
With Blair?
Yeah.
She loves our creatures, great and small. Biped, millipede, no pet at all. If you want to hear about animals, she's your girl. Except for giant pandas and squirrels. There's Animal Corner.
What you got, Blair?
Well, since you just talked about bees, I will go ahead and jump straight to my bee story. So fun.
Go with your bad self, Oprah.
Yeah. So I don't know, but I'm just going to go with it. I'm going to go with the flow, which is actually what my story is about.
Okay.
Have either of you ever seen a bee in a pool or a pond and thought,
Oh, yes,
no,
they love swimming.
you're in trouble?
No, when they're in the water, I've tried to save them. I can splash them out of the pool. Don't be in the pool. You don't belong here, little bee.
Well,
You're racist.
we have new breaking news on what's going on with those bees stuck in water. This was actually discovered by Chris Rowe.
Wait. Just
Yes.
stop. You mean they're not drowning?
Not necessarily.
Oh, okay.
Yes.
Okay. All right.
Yes. So research engineer Chris Rowe was on Caltech's campus, and it was during the drought. So the fountain was turned off. So the water was still in the fountain. And he stopped by this fountain around noon. So the sun was overhead, and there was it was casting a shadow of a bee in the pool, presumably drowning. And the shadow of the bee was being cast onto the floor of this fountain. What he saw was something very interesting. He saw waves being churned by the flailing bee's efforts on the pool in a very particular pattern. As this bee struggled to make its way to the edge of that pool, he noticed the shadows showed the amplitude of waves generated by the bee's wings. Leave it to a research engineer to notice these things, and you're just looking at a bee in a fountain. And that interference pattern created by the waves from each individual wing as they crashed into each other made him go, aha! So then they captured 33 bees from the wild, placed water in a pan in the lab, allowed the water to get completely still, and then dropped the bees in one at a time. And as each bee flapped around in the water, supposedly flailing and drowning, filtered light was aiming directly down onto them, created shadows on the bottom, and they could actually chart what was happening there. After a few minutes, they were carefully scooped out, so none of them drowned. They recovered from their swimming efforts. But what we learned from this was that when a bee lands on water, the reason they look like they are in this death throw is that the water sticks to their wings. And so they're grounded.
Surface tension.
They can't fly. Yes. So they broke the surface tension. So they can't fly. So, you assume this bee, it can't fly away. It's doomed. However, the stickiness is only on the bottom of the wing, which allows the bee to drag the water, creating waves that actually move it forward. The wave pattern is symmetrical from left to right, and it's a strong, large amplitude wave with an interference pattern generated in the water at the rear of the bee, which means it's pushing them forward. And while the surface in the front of the bee lacks that large wave and interference, that shows that this disproportionate wave pattern is in fact pushing it forward. That propels them forward with the slightest of force, which is why we don't really notice it. We think they're just dying. It's about 20 millionths of a Newton is the force. So for reference, an apple in your hand is about 1 Newton. Ha ha ha. That's where it all comes from, right? It's from gravity. So yes, so 20 millionths of a Newton. It's very, very little force. So they are basically creating a wave that they're riding forward. So if they flapped up and down normally, they might not get anywhere, and they might break that surface tension and get the top of their wings wet, and it would all be done for them. They'd sink. So instead, they have this curve upward so that it's like, I was thinking about how when you do freestyle, when you're swimming, you're breaking the surface tension and then you're kind of scooping. So it's kind of like that. They're creating this scooping motion in the water so that they're moving forward. So for those audio listeners, if you were watching right now, it would not help the explanation, I can guarantee you. But I'm working out my biceps real well. So the pulling motion provides thrust. The pushing motion is a recovery stroke. So they are, in fact, moving forward. They're moving their wings slower. If they move too fast, they could also break the surface tension and sink. So it's less than 1/10 of the speed of when they're flying in the air. And so this appears to be entirely intentional. They can't do this forever. If they fell in the middle of the ocean, they would not be able to do it because it's actually way more tiring than just flying.
So they actually are good swimmers, but they actually are also like kind of drowning. Like they're looking for a way, something to climb out on, like looking for something floating in the water, like a leaf to get on top of to sort of and then fly away.
Yeah. So again, because they can't fly once they hit that water, they're stuck there. They're trying to find an edge so they can walk out, basically. So they're trying to find an edge so that they can grab on or walk out of the water so that they can then kind of shake off and fly. So the ultimate goal there is just to get them to the edge. They think that they have enough activity for about 10 minutes of this motion before they would get tuckered out. So this is a very clear window, about 10 minutes, during which they can escape a watery space.
So to everyone coming to a pool or a body of water where you see a bee, if the bee has its nice little flappy motions, the bee's still doing fine. But if it seems as though its wings have gone under the surface of the water, or if it's not pushing anymore, that bee needs help.
Yes.
And they need help in both cases.
They do.
Always rescue every bee in
Rescue
water.
the bees.
Yeah, and I think that's right. Just you might think after hearing this story that giving them a nice push, like creating a larger wave, might help, but that actually is more likely to break the surface tension and ruin it all. So scoop them out of there if you can. And help them on their way.
Or if you want to watch what they do to dry off, you can take like a stick or something and kind of just sort of set it in front of them for them to climb up on and hold it, and you can watch them sort of dry off really quickly before flying away.
Which is also fun to watch. But okay, I'm just wondering, Blair, is this now going to be used to create robot bees that Could
Yes.
swim.
Yeah, that's the plan. Yeah. The main idea is that this motion could be used to generate robots that could both fly and swim. That's the next step.
Mhm.
You got it.
They can do it all.
That's always the next step. How can we turn this into a robot?
Yeah, I don't know. I mean,
Especially when you're talking about engineers. Yeah.
bee can fly and swim. I think if I'm designing a robot, though, I think there's better swimmers. Is all I'm saying.
Like a pelican?
Yeah, something
That's
like this.
something that can fly and swim.
Yeah.
You're right.
Oh my. Yeah. And would make a much cooler
An
looking
auk,
robot, in
the
my
northern
opinion.
hemisphere
auk.
version of
Mhm.
a penguin that actually can fly. Yeah, there you go.
Flying penguin.
There you go.
Flying penguin and auk. So moving on to other modern marvels in the animal world, I have a lovely story to tell you about another amazing discovery that just was happened upon. This was by Lindsay Doherty when she was an undergraduate student at CU Boulder in 2011. She was just scuba diving, just checking out the stuff in Indonesia in the corals there, and came across, you guessed it, the disco clam.
Wait. When was the last time we talked about the disco clam?
It's been a long time.
Not since 2011, though, right?
No.
No, more recently than that.
No. So the disco clam, this isn't just about the existence of the disco clam. This story is deep because it combines the disco clam and another show favorite, the mantis shrimp.
Ooh,
Together
wow.
in
This
one
is like-
story?
Yes. So it turns out that these two have a bit of cat and mouse going on. They are the predator prey in a very specific ecosystem. So the disco clam, of course, is the prey. That stabby or slammy of the mantis shrimp is the predator. So first, let's start with the disco clam. Called a disco clam because they look like a normal, just kind of whitish clam on the outside. But when they open up, they have these bright red appendages that poke out that look like tentacles. They dangle out of their shells. They wag them around. And then on the inside, right where those tentacle-y things hit the inside meat of the clam, there are these thin strips of tissue that pulse. They look like a strobe light or like a disco ball, which is why they're called the disco clam.
It's like LED strips in a disco. Yeah.
Absolutely. And so
LED lighting.
that's where they get their name from. But there's lots of questions about how they flash. There's questions about why they flash. And that's where this story gets interesting. So first, where we started our story, Lindsay Doherty, when she then went to her graduate degree at UC Berkeley, she spent her time figuring out how they flash. And it turns out it is tiny silica spheres in their tissue, which I think is what we reported on the show, however many years ago that was. Now she is back in Colorado as an instructor in the Department of Ecology and Evolutionary Biology, and she is taking this to the next level. Why are they so colorful, and why do they flash? And this is a particularly interesting story because she's not just using graduate students to figure this out. She is using high school students. More on that in a minute. So peacock mantis shrimps, they can break open these disco clams, which if you think about it, the main bread and butter of a clam and how they do what they do is by being impenetrable. So they close up tight and nothing can get inside of them. But if the mantis shrimp has this amazing ability to smash through pretty much anything, then that reduces the efficacy of having a clamshell in the first place. So they had to do something else. So the idea was, is this some sort of discouraging coloration to say, leave me alone, don't eat me? So they think it's a warning signal to predators that either they're poisonous or they don't taste good. So how do you test this? Well, they first took mantis shrimp in a lab and they offered them a choice between two types of disco clam tissue. The first was bright red meat from the exterior, and the second was the white meat from their inner muscles, which in theory even if you had bad tasting tissue on the outer edges, or if you were poisonous on the outer edges, it wouldn't need to be that way all the way through. You only need to stop somebody from opening you up, right? So they wouldn't, that tissue would in theory be just like any other clam tissue. The mantis shrimp, hands down or claws down, preferred the white meat. They had no interest in the red tissue at all. In fact,
they're not into the dark meat.
Yes, some of the researchers said they, quote, hated it. They were totally uninterested in it.
Wow.
So then, this is where gets really interesting. The group offered the mantis shrimp white meat that was dyed red, but they ate it. My first question is, mantis shrimp they have 12 different types of cones, I think it was.
Color receptors, yeah.
So they have so many more ways of seeing color than we think. How do we even know we're dyeing that meat the same red that they see? So I feel like this is a whole extra thing where I'm like, I don't know about the efficacy of this test method, because how do you know what a mantis shrimp sees?
Mm-hmm.
That's really tough. However, the theory is that it has something to do with taste and it's not just color. So what kinds of food taste gross to a mantis shrimp? And this is where they brought in high school students. They actually brought in high school students to spend their semester trying out different flavor combinations, feeding things to mantis shrimp. And so they took supermarket shrimp meat. They would dip them in sriracha or vinegar or anything you can imagine, just to see what the mantis shrimp liked or didn't like. And then if they found that the mantis shrimp thought something was, quote, yucky, they'd mix it with meat dyed red to see if over time they would become wary of that hue regardless of taste. So this is trying to see if coloration
plays a factor.
If they can learn, if that is a learned association. So I think this does maybe solve that problem that I brought up, which is how do we know we're doing the right red? So this is just saying, okay, we'll pick a red. We don't know how they see it, but we will pick a red and we will create it as a bad link. And then if they start to recognize that red as bad, then we know that something about the color of the disco clam is warning them to stay away because they don't taste good.
The color rate, yeah. I mean, if that is their main predator, if the mantis shrimp is the main one that's after them, this kind of coloration could totally have evolved over time to be a warning signal.
Yeah. So this video, I love this video because it shows exactly what I was talking about before, that if a mantis shrimp can penetrate a clamshell, there's no reason to clamp down. So the disco clam does the exact opposite of what you would think you would do in the sight of a predator. They open up and stick out their tentacles and start strobing. So clearly that is a warning signal. That's some sort of flashy signal to say, hey, stay the heck away from me.
I don't taste good.
And also, I wonder if that adds protection to the shell, though. From a thing that's got a smashy bit, if you're just lying still, versus when it hits and the clamshell is still open, it might have some motion that can absorb some of that impact. A couple of ways but it seems very specific then to the mantis shrimp. Like that might not work on everything. Like other things, like you're open, I'll just go in and eat.
Right.
I like the red stuff.
Yeah, I don't know. That's probably why they still have a clamshell, is so then if the mantis shrimp leaves, then they can shut her down. Yeah. They need to.
But I think Justin's right about that too. I mean, if your shell is damaged, then that is going to make you vulnerable to all sorts of attacks from other animals or even from infection. So it becomes it's kind of like the honest signaling that takes place in deer species or in rams or other animals that could potentially get in a fight and end up injured. They don't want to go there.
Yeah, that's true. And I also wonder, it doesn't necessarily need to be taste that's bad about this red tissue. It could be something that upsets the mantis shrimp's tummies. It could even be poisonous. Have we tested for poison? I don't know. There's other things it could be.
Not
Just
just
a
a,
thought.
not just a, not just, I don't like how it tastes.
Yeah.
Yeah, well, they could just be allergic
I'm
Yeah.
to
allergic.
that
I'm
part.
allergic to disco clam.
I'm allergic to the red part of a disco clam. Thank you very much.
I want to know more about this exciting relationship between mantis shrimp and disco clams. I mean, seriously, the peacock mantis shrimp and the
Yeah.
disco clam. I mean,
Match
just
made in heaven.
it is.
It does sound
It's
like
a
one of those
band
weird
name.
mashup movies.
Mhm.
Frankenstein meets Sasquatch.
Yes, exactly. Disco clam meets peacock mantis shrimp. Yes, and it sounds like this is a really rich vein. There's high school students working with the University of Colorado to study this, and I think they're only at the tip of the iceberg here. Mantis shrimp, they have so much to teach us. And it turns out so do disco clams. I love them both.
We all love them both.
The Wolfman meets the Loch Ness Monster. A love story.
Meanwhile,
lob
in Justin's
story.
head,
It's Lob Story. Oh. All right. We're going to take a break. It is time for us to say a few words about some other things. And when we come back, we'll have more science for you. And also our favorite segment, What Has Science Done for You Lately? We'll be back with more This Week in Science in just a moment. Stay tuned.
Can't explain things you've heard with more than intuition. A line breeze that shows the way to go. New conclusion. The methods of hypothesis and patience are the only things I need. Put on a pair of
Put on your goggles, or your headphones, because you're probably listening to This Week in Science right now. I hope we're in your ears. Are we getting into your head? Worming our way into your brain with the science. If you love what we bring to you every week, please consider supporting what we do. An easy way you can do that right now is buy a calendar. That's right. It is time for the TWIS Blair's Animal Corner 2020 calendar. And if you go to twis.org, you will find a link to be able to purchase your own calendar for 2020. It's got sciencey dates, wonderful original artwork from Blair, and it tells you when TWIS is going to be on Wednesday nights at 8 p.m. Pacific time throughout the year. That's right. It's well planned out. We've done our best to tell you what you need to know for the upcoming year. We hope that you will get yourself a calendar, get a friend a calendar, maybe buy a few for the holidays. The holidays are coming up. Makes a great gift. That's right. This calendar is pretty special, and we hope that you will get yours now. Go to twis.org to get your calendar. While you're at twis.org, you can always check out a few other things. One thing that will help us out especially is clicking on that link to subscribe. That's right. Click on the subscribe link while you're there. If you're not subscribed, you'll be able to subscribe through YouTube, iTunes, or the Google Play podcast portal. Additionally, if you've already subscribed or you've gotten your friends to subscribe, you can go over to the Patreon link. Clicking on the Patreon link will take you to Patreon. Patreon.com/thisweekinscience is where This Week in Science has our community on Patreon. And you can choose to support us at one of our monthly levels. That's right. You support us at the level of your choosing. And it's charged once per month. And in return, sometimes you get some special little gifts back from us. But really, you're helping an independent podcast to continue doing what we do, to buy the equipment that we need to really maintain the weekly schedule that we've got. And the more supporters that we have, the more we can do. It's really, really true the way it works out like that. But if you can, $10 a month and more is what you need to, the level you need to choose if you want us to thank you by name at the end of the show. That's right, $10 or more a month. But there are levels for all sorts of financial situations. So click on that Patreon link, help support us. Click on the subscribe link, subscribe to This Week in Science, and buy a calendar. It's really true. We really could not do any of this without you. Thank you for your support.
Can't explain things you've heard with more than intuition. A line breeze that shows the way to go. New conclusion. The methods of hypothesis and patience are the only things I need.
And
We're back. You're listening to This Week in Science.
that's right. We are back. Welcome back, everybody. And it is time for that part of the show that we love to call This Week in What Has Science Done for Me Lately? Slow on the uptick.
I'm like
It's all
5
good.
seconds behind with everything tonight. I'm so sorry, but I'm here.
It's
I
totally
exist.
fine, especially because I have a story to do with poo in the second half of the show, so it's great. Yes, okay. I didn't tease that one at the beginning of the show, although maybe I should have.
You should
That's
have.
right.
Maybe my dog would have listened to you then.
It may have helped, but this is the "What Has Science Done for You" segment. Let's not talk about poo. Okay, our letter for today. What has science not done for me? There isn't anything that science has not done for me. Between saving my dad, who was an aerospace engineer on the Hubble telescope who worked on the solar arrays, and helped a dear friend who had an ectopic pregnancy, to just me driving my car to work. I run a high-end restaurant. Everything from the kitchen to the lights to the plumbing, septic, and so on is all science. There's nothing that you do that has not been affected. Not sure if that's the right use by science. It's everywhere you see, smell, touch, feel, and as you should, love. You all are the best, even you, Justin. That was totally a joke because of the last person who ripped you. Continue your work, please, and educate the next group of people. Thank you, Isaac Bonaker. And then Isaac goes on to say, I do want to elaborate on my dad. He was in an accident and lost the use of his left arm, that being his primary arm. With training and help from, again, science, he was able to retrain his other arm and complete his goal, being a part of science. He was a part of building the most important scientific device of the 90s with one arm. Without science and determination, a key factor, my dad, Stephen Bonaker, would not have been able to be a part of a program that has changed the views of almost every scientist. I am proud to be a product and a part of science. By the way, besides being a chef, I brew beer, wine, and mead, which is all science. Keep it up.
Thanks, Isaac. Also, a taster of your beer would not be unappreciated. We'd like to taste the science as well,
We do.
This
love
is what
tasting
this
science.
is like. What is this? Somebody please buy us beer show?
No, it's not even that. I love that idea of people brewing at home, and I don't know, it sounds fun.
It's very fun. Absolutely. I love the mead reference. Justin, you mentioned mead when we were talking about the yeast and honey story. Maybe there's a lot there. I mean, how much does the yeast go into changing the flavor of the honey and potentially affecting the, product output, right? The taste of the mead or whatever. How would it work? We don't know. That would be a great thing to study. Isaac, thank you so much for writing in and reminding us. Yeah, I mean, we ask for usually the one thing, what has science done for you in a little way lately or a big way or whatever, but it's all around us. Science is everywhere. Really, in our modern world, it affects everything. it's touched everything, and I really appreciate your letter. And the story about your dad working on Hubble with one arm, and
So cool.
Yeah,
Hubble
that's awesome.
really, I mean, do you two agree? I mean, Hubble is seriously the tool that allowed us to view the universe in a completely different way.
Mm-hmm.
Yeah, I mean, there's open access images because of Hubble, right? I mean, like it makes understanding our universe accessible to everyone,
Yep. So
or at least
hugely impactful.
understanding what we don't understand and understanding how big the universe is, which I think is really what it's about, right? Is recognizing how big the universe is and how little we are, and it's actually really cool to know that.
So cool. It's okay to be small. It's okay.
Yeah.
So it's pretty cool
It's
to be a part of this
awesome.
big,
In the
full of
actual
awe.
meaning of the word.
Yes. So being an Earthling is basically Earth is just an address within our galaxy.
Yeah.
If you leave the galaxy, if you're talking intergalactically, we would be referred to as either Milky Waylians, Milky Asians, slightly derogatory, just Milkies.
The Milkies.
Milkies.
I mean, maybe we should be named by the black hole that we're traveling around, which would make us Sagittarians.
Oh yeah, there you go.
Oh.
That's
Justin and I would appreciate that. We're Sagittarian.
Yes, you are. Yeah.
And a radio telescope in the Western Australian Outback actually just took a look at our center.
It did,
At our
but
black hole.
It did. But I would like to tell everyone again, reminding them that we need your stories to keep the What is Science Done for You Lately segment of the show going. We need your stories. Send them to me, Kirsten at thisweekinscience.com, or leave a message on our Facebook page. Makes it easy. Let's keep it going. Send me a letter. Send me a note. Send me a haiku. Something. Okay. So, Milky Way.
So
Taking a
yeah,
look
the
at it?
Milkies tried to look at their own black hole. Astrophysicist Dr. Natasha Hurley-Walker from the Curtin University node of the International Center for Radio Astronomy Research has created images using a supercomputer in Perth. So this the new view captures low-frequency radio emissions from our galaxy, looking both in fine detail and at larger structures, she says. Our images are looking directly at the middle of the Milky Way, towards a region astronomers called the Galactic Center. They got this, the survey has a resolution of 2 arc minutes, which they say is about the same as the human eye, and maps the sky using radio waves at frequencies between 72 and 231 megahertz. So that's FM radios around 100. So this is as pretty reasonable frequency range. It is the power of this wide frequency range that makes it possible for us to disentangle different overlapping objects as we look toward the complexity of the galactic center, says Dr. Hurley-Walker. So this is, of course, towards the middle, things are more dense, and so you could just get a fuzzy ball of, yes, there's stuff there. But this method they are using, they're being able to distinguish different objects towards that center instead of it having just a glowy core there. And what they're finding is pretty interesting. Using the images, they one of the things they discovered were the remnants of 27 massive stars that supernovaed at the end. And so you have these sort of fossil relics back there and towards the center. Sort of interesting too is they also found the remains of a star that died less than 9,000 years ago, which they think could have been visible from Earth 9,000 years ago. And they are reaching out to the indigenous community, the Aborigines, who have in their storytellings, in their traditions, make mention of observations of supernova quite often. So they're actually looking for a correlation to see if this was captured by a verbal tradition that has gone on for more than 9,000 years, much
I would imagine it would be captured in verbal tradition. I mean, yeah, Aboriginal culture goes back 50,000, 60,000, and
Yeah.
Native American culture here in the United States goes back, what, 13, 14,000?
Oh, much longer.
Yeah.
Double it. Well, pretty much double it. Yeah.
We don't know that.
Yeah, pretty much.
Do we?
Yeah, there's sites in South America that are established with agricultural sites and everything that are more than 14,000 now. That number, that 13,000 number was the pushback from the 7,000 number, which was the pushback from the 6,000 number, which is we're beyond Clovis now. Clovis is 13.
Amazing.
We're much further back. But then I might as well jump ahead into the next story because it is sort of related. 4.5 billion years ago, something brilliant happened in a galaxy far, far away. About 4.5 billion light years away, actually. The details of the event are still a bit foggy, but it may have been the collapse of a massive star or the collision of two previously collapsed stars running into each other. Whatever the cause, the result was a brief and extremely powerful cosmic explosion that created a GRB, which is the cosmic lingo for gamma ray burst. Well, truly amazing. Gamma ray bursts happen every day. They're about 360 or so a year. They start with an initial bright flash, which is called the prompt emission because it happens so promptly, with a duration ranging from a fraction of a second to maybe 100 seconds of this bright period. The prompt emission is then accompanied by the afterglow, a less brighter but longer lasting emission over a broad range of wavelengths that then fades with time. This is what we see from these distant supernovae. Catching one in action is tricky because they happen so quickly, and what we are usually looking at and what we're usually talking about in terms of supernova events is the afterglow itself. What scientists needed was to capture a GRB in real time, and so they turned to magic. Yes, scientists used magic. The telescopes in Spain, aka Major Atmospheric Gamma Imaging Cherenkov telescopes, these Cherenkov radiation observations. And this event, this supernova or this GRB event happened in January of this year. It was first discovered by two space satellites that were relaying information about the event within 22 seconds of its being observed. Its coordinates in the sky were then distributed down to astronomers worldwide, which magic was set to automatically direct itself towards, which it did within 50 seconds after the beginning of the GRB event. So this gamma burst happens. It's detected within 50 seconds. This telescope is looking at it, and the photons detected by magic were the highest energy we have ever seen from one of these events. In fact, it is the most powerful GRB signal, gamma ray burst signal we have gotten to date. Clearly distinct. I was saying is clearly distinct from the physical processes that are known to be responsible for the emissions that we've been seeing in the afterglow, which was thought to be a sort of vortexing or spiraling through magnetic to get to those energies, which are, I'm calling them lower energies, but they're lower than this. They're still gamma ray bursts. They're still very high energy. The analysis resulting from the data, the first tens of seconds revealed emissions of photons in the reaching the tera-electron volt energies.
Mm-hmm.
So that is a trillion times more energetic than visible light. And it was the emissions of the TeV photons from the burst was 100 times more intense than the brightest known source of tera-electron volt energies, which come from the Crab Nebula. So most powerful. And what it does also is it hints that the way in which these had to be created aren't based on what we've known today or what we suspect today. This is Lara Nava, scientist associated with the Magic Collaboration, says, from our study, the most likely origin of the TeV emission is the so-called inverse Compton process, where a population of photons are significantly kicked up in energy by colliding with high-energy electrons.
I was just looking up how strong a tera electron volt actually is, and it's like, this is so much energy. This is trillions of times stronger, than a photon. This is so much energy. But when you think the CERN has a website, the Large Hadron Machine Outreach website, and they say that 1 tera electron volt is about the energy of motion of a flying mosquito. So
we need to harness the power of mosquitoes.
Yes.
Yeah, apparently, according to science, they're the most powerful energy source in the universe.
It's very powerful compared to how much energy would be just in a normal photon or
And when we're talking about a normal photon, that comes from a nuclear fusion in a giant star.
Yes.
That's really normal light.
The energy that allows our cells to be activated so that we can see a flash of light, a spark of light. That's 1 photon, right? That amount of energy that can activate our ganglia in our eyes. But yeah, a mosquito's worth is coming from outer space, and we've detected it. Well, it's like a lot of mosquitoes. It's like a mosquito swarm.
Mosquitoes that can travel 4.5 billion light years.
Light years.
Those are mosquitoes you don't want to mess with.
This is going to be the most amazing space cartoon. It's like a swarm of space mosquitoes traveling billions of miles. Yeah. This is exciting. High energy. Let's find out what are these gamma ray bursts going to tell us, though?
So they're going to tell us a little bit about some of the processes that are involved in supernova.
Yeah.
And I guess part of it too is this is either supernova or potentially it's 2 previous supernovas that are then colliding together, neutron stars. So collapsed versus supernova. Sorry, collapsed stars. So anyway, it's going to tell us more about those processes because we haven't really observed this level of energy coming from one of these events before because we keep getting there too late.
Mm-hmm.
It's like showing up at the party and saying, okay, apparently the party a party is made up of people emptying cups and placing them on the floor. Placing empty cups everywhere on the floor, that's what a party is. Well, no, there was a thing before that. You just keep showing up late and thinking it's just people making a mess. There was people having fun and music and conversations going on you had no idea it took place. You just think it's people trashing houses. So, so getting there early, being able to, and now they think because these are relatively common events, this worked well with magic. I also assume they must have been, the planet must have been facing the right way, and it had to be lined up perfectly, right? To an extent for it to be able to even direct these telescopes there to get the signal. But maybe we need a couple more of these setups, telescopes around the planet, so that we can capture more of these events more quickly and have them tied into automatically direct when we get the GRB signals.
Very cool. That would be very cool. Let's find more of them. And then if it's neutron stars, we can then do the pinpointing and triangulation with the LIGO Virgo array and all that. Yeah. Yes. Yeah. Maybe we can triangulate with the merging of black holes and all sorts of stuff. Yeah. I'm excited about all this. You know what I'm also excited about? This study about broth very yes.
Mhm.
It's not actually like a super thrilling study, but I love the methodology, what it means, and also how it involved children. So this is published in BMJ Journal's Archives of Disease in Childhood, and researchers wanted to study the possible anti-malarial properties of homemade broth. Turns out that ancient Chinese medicine has heightened interest in natural discovery of future antimalarials. The discovery of artemisinin, which is one of the main malarials, came as a result of natural discovery procedures. And these researchers looked at the tradition of families in various areas of the world, various parts of Africa, and the study did take place in the UK, but they had kids from very diverse ethnic origins whose families had come from a lot of different places bring their family recipe broth to school. And these broths, extracts were taken from them, and then they used these extracts to try and see how they affected various stages of the Plasmodium falciparum, which is the parasite that gets into the mosquitoes and causes malaria. They checked how it affected the various life stages of this parasite, and they found there were 56 different broths that they tested. 5 of them were found to give over 50% growth inhibition against the early blood stages of the parasite. 2 of them had comparable inhibition to what is seen with dihydroartemisinin. So it's comparable to the currently used drug of treatment.
So does that mean most of the children survived the exposure to malaria?
They didn't give the kids malaria.
Oh, okay. Okay.
No,
right, okay.
they
I
were
was nervous this whole time that this was
extract culture, in vitro cultures, not actually giving kids malaria.
Gotcha.
They were just seeing in dishes how the broth extract affected the parasite. They didn't give it to the kids. Oh my goodness. 4 other broths had over 50% effect on transmission blocking activity. It prevented male parasite sexual stage development. So it reduced the probability of males going on to become sexual and to propagate. They also found that after they unblinded everything, so this was a double-blind study, they didn't know whose broths came from where until they unblinded, and then they found that 2 of them came from siblings who were from different classes who had brought in the same soup. And so they kind of proved their assay.
Handy. Yeah.
Yeah.
That's really
Proved
handy.
their assay. Anyway, this study, they demonstrated not only this really interesting impact of traditional nutrition on what we know to be infectious disease. So these are family recipes from areas that malaria is prevalent. And it's interesting to see that some of these soups that it's like, oh, you're sick, drink some soup. It'll make you better. That in some cases it may actually make people better. That some of the recipes get something right.
Well,
and
wouldn't it be a natural selection of recipes?
Sure, but not
Because like, it's only the family recipe that actually has an effect on malaria is the one that ends up being most prevalent in that society, just because people who were
that's who survives
eating toast, had been given toast when they got sick, all died.
I mean, it was a small number though, 5 out of 56. So it's it's interesting that there's such a small percentage out of all the different broths. The other aspect, though, is that they involved the school kids. The authors on this paper, the first authors, are the children of Eden Primary School. So the kids who brought the broths were involved in the scientific process, the scientific discovery, and this paper is their work.
That's our second study tonight that has people participating in the research who are under 18, the youths.
The youths.
I love it.
Yeah. Yeah, it's education, and they're educated on the scientific process, and then they're part of the publication process. It's not, all of it, which is very exciting. Let's see. I guess you did your stories, Justin, so I'll just run on to mine. And of course, if you're sick, well, I'm not going to say those words, but there's another study that I need to talk about, toilets.
Let's talk about toilets.
Yeah. Who likes cleaning toilets?
No one.
I like clean toilets. Wait, nobody
You
likes
like a
clean
clean
toilets?
toilet?
What are you guys talking? How do you not like a clean toilet?
I like a clean
Who
toilet.
doesn't like clean toilets?
I do not
would
enjoy
have
cleaning
guessed.
toilets, but we
I don't
do
like
this.
cleaning them.
Yeah, they're kind of gross. I mean, sometimes there's leftovers in the toilet, and why does it stick? Well, I guess poo is a little bit sticky, and
That checks out.
and to get rid of it, you either have to have a brushy, sticky thing, or the original flush has to use a lot of water to drive everything down into the sewer, the septic system. And so there's the potential for saving a lot of water if the poo were not to be stuck to the toilet.
Is this going to be a Teflon toilet story?
It's
Sounding like
Non-stick
it.
toilets, the thing of the future.
It's not
Complete
Teflon, but it is a different material. There is a new synthetic material that researchers have just published about their development of this material in Nature Sustainability, and they have published about their compound they are calling LESS, L-E-S-S, for liquid entrenched smooth surface. This is a sprayable, non-fouling coating that increases slipperiness. And what they found for a standard toilet using 1.6 gallons to flush, every 1 milliliter of this coating could save about 1,000 liters of water.
But so wouldn't you have to adjust the way toilets flush as well then? Because you're
Yes.
saying that you need less water. So
Right.
it would be a
So-
two-pronged approach.
Yes, absolutely. This would be a two-pronged approach to saving the water. First, it would be coating the insides of the toilets with less, and then it would be reducing the amount of water that goes into them. And so it would be, they imagine this being used by utilities, by companies that, where they have large numbers of toilets, and corporations and buildings where there are people managing these systems, and they can be monitored and managed. I'm just going to say, though, that this study, they went to some great lengths to prove that they had created a worthy compound.
My
Initially,
question is, what species was the poop from?
human.
Oh,
Anonymous.
They really did it. They really
Anonymous
did it.
donors, yes. So they have they tested spray saline solution versus a spray lubricant like Teflon, or silane, and then their less coating, which they have created. The initial tests were done with an artificial poo. They made synthetic poo.
I'm sure they did.
They did. They made it to be approximately the stickiness and of feces, of human feces. And then they tested it on their different surfaces to see which worked best. They found that their less worked best. They went on from there, from sliding it down to plopping it down, sliding it down little pieces of glass. They also tried it in toilets, and actually checked to see how it worked in toilets. And then they moved from synthetic poo to anonymous donored feces, real poo. And they went to great lengths to prove that they can reduce the amount of water that we use when we flush our toilets.
So I know I'm always usually the hopeful person who's like, this is great. I can't wait for this all to work. This is something where I am kind of a pessimist because we have had two-flush technology for literally like 40 years and we're not really using it. And that cuts water consumption in like less than half just by doing that. And we can't even do that. We can't even install a second handle on our toilets. Are we really going to install brand new toilets that are coated in this thing that do a completely...
you would have to reapply the coating every so often. Apparently, it should only they think it'll only last through about 50 urinations or maybe 500 defecations.
Okay, so now I have two more questions.
Yes, this is where my questions go.
This is a huge cost then. This is something you're asking people to remember to buy and also then to spend money on. And also, what if you run out of that and then you're still flushing with less water? Then that's a whole problem. My whole other question is, that means this stuff is getting flushed.
Yes.
Which means, what is it going to do to our water column?
Where's it going? And that would be the next question. So they say it's non-fouling, but what does that mean? This is a new compound. We are releasing so many compounds into the wild and they are having effects. So what potential effect would this have? Is it that it is breaking down into, and the reason that it's not sticking around is that over time it just breaks down and it's going into little tiny components that really are fine in the environment? Or is it that it's just little pieces of it are ending up in the environment that could cause problems? I think that is the interesting question at hand. But
that's the question.
That would be the question.
You know, I also wonder if this is at all necessary. I mean, I like the idea. Actually, I really love this idea. Non-stick toilet. It seems like we should have invented that well before the non-stick pan.
Yeah.
Okay. that's not already a thing. I don't know. I now do not understand. However, the other thing, you know, when we're talking about water conservation, and this is the thing from the California drought statistic that just kind of blew my mind, is that personal use of water is about 10 to 11%. For all of the 40 million people in the state of California, the other 89% is for industrial use and commercial use. So you know, the real place where this might be of some sort of a benefit probably is outside of the toilet, right? It's there is probably a manufacturing process of some sort that would utilize this to a much greater efficiency in terms of water conservation than home toilets. But then you're talking about, in this particular, if it's a spray-on and the compound going down, that means it's much greater usage and contribution to the water column than a home toilet would as well. So,
yeah, what did you say? 50 urinations? That's not very many.
It's not very many.
Yeah, because that's how you clean a toilet. You just pee on it. You don't have to scrub. You just hit. If there's a sticky spot, you just hit it like 3 times. And
I just got some real insight into your cleaning technique.
Also, I'm going to say there are certain members of the population who have more aim than others.
Well, yeah. I mean, this is if you're a guy living alone, this is what you do. No guy living... Okay, guys living alone, clean toilets maybe once a year.
Yeah, that sounds about right.
Maybe.
Yeah. Oh, geez. Well, I mean, they say the numbers at the end of their paper here, they say that we have shown that the less coating is capable of reducing adhesion up to about 90% for soft viscoelastic solids and requires only 10% of the cleaning water required for an untreated control surface. 10%.
But then to Justin's point, how much water is used in the factories that make this product that you buy at the store?
Yeah,
Great questions.
I think
Yeah, cradle to grave. What's the whole story?
I think that there is a solution in here. I don't know if this is it, but at least what they're working on makes a lot of sense.
Yeah.
Non-stick toilets. How come?
But I think it needs to be the material the toilet is made of. I think that's the kind of the mistake here is to have it be a spray that you just add onto a toilet.
Right. Can you put it in the paint that goes on the ceramic coating, the coating of the ceramic? Is there something that you can do? Yeah.
Yeah, or look at how the molecular structure is and see if you can just make the porcelain that way.
Mm-hmm.
Yeah.
Oh,
I mean, I don't think maybe I'm giving an unsolicited plug, but it's like the copper ceramic chef pan toilet. Like this is like, don't we have this technology?
That's what I was wondering too. Yeah, like you were joking saying Teflon toilet. Like that sounds more.
That sounds insanely practical.
That sounds better.
Yeah, and you're not heating it up. You're not heating it up.
You're not heating it. Exactly.
Too many great. So you might be avoiding some of the follow-up. I feel like this is like a $1 billion idea that like somebody should have come up with a really long time ago.
That's right. You heard it here. We're going to see it on Shark Tank next week. Non-stick toilets. Oh my goodness. This story. Yeah. Love this story. Okay. There's a new dinosaur bird thing.
Yay!
Oh yeah, I heard another precursor to flight of some sort.
Yes, another precursor. It's super cute. Its name is Fukuipteryx prima.
Nice.
Yes, Fukuipteryx prima was found in Japan, and it was they as so happens. Archaeologists were just digging in a little place and they're like, what are these bones? Oh, it looks like a bird. Oh, look at this. It just, they're calling it a missing link. But as we know, missing links that's not a real thing. But
wait, aren't there? Wait, why not? Oh, okay.
They died out.
Oh.
But it is an organism. It's a bird-like predecessor to birds. It has what's called it has a similar bone structure at the tail end where the flight tail feathers would have attached. It also has claws on its wings, which was similar to Archaeopteryx, which probably predated Fukuipteryx. And so it's somewhere in there between Archaeopteryx and modern birds. It's a non-dinosaur bird. It's got a tail nub, just like birds of today.
It looks kind of like a shoebill sparrow.
Yeah.
How big were they?
These... Whoa. Something just turned on and I don't know...
What?
Oh, you're hearing sounds.
Where are those sounds coming from? Oh my God, that was weird.
Is there a ghost?
There was a ghost in my web page.
Yeah, that happened.
Hidden pop-up sideways ad sound audio coming from like.
And it was Homer. It was Homer and Bart Simpson, so it was really distracting.
I'm trying to
I don't know what was going on. It was
how big they were. I don't see it in the article anywhere.
Yeah,
Which seems like a weird oversight.
Yeah, I'm not exactly sure how big they were, but
interesting. Somebody tweet at me if you know the answer. I'm very curious how big these things are. Yeah, I don't see it in the article anywhere.
The fossil differs from those found in China's Johol biota, which are smooshed and look like bony pancakes. It looks very similar to some of the earliest birds that evolved about 30 million years earlier during the Jurassic. It has a bony pidgestyle. That's the nub. But I do not know how big it is. Yeah. And
okay. That's fine. Because for some reason that artist drawing, the rendering makes it look like huge. I don't know why. Something about the picture itself, I imagine it being huge, but I know it was probably not.
Yeah, I want to find length measurements, but 3 centimeters. I don't think it was that big.
Yeah, teeny. Probably like
Wait,
a little
how
sparrow
big?
thing.
A pigeon's. It's pigeon sized.
Great.
That's the size of a bird. That's a good sized bird.
Pigeon sized. There
There
we
you
go.
go.
I found it. It was pigeon sized, very bird like, and pigeon.
You said-
Yeah.
you said- okay, that's for somehow I don't know why. Did you say 3 centimeters?
No,
Or
no.
did
I was going
just
through the
reading out
article
loud?
and there.
One
I
of
was
the
reading
items
out
or
loud. It
something.
was one of the
Yeah,
items I
because
found.
I'm like,
yeah.
that's a very small bird.
Yeah.
That's an amazingly small bird. I don't know that I've seen a bird that small.
No.
Not that small. No.
Although I think isn't there a hummingbird that's supposedly like something.
Pretty
3
tiny.
centimeters? No.
Not 3 centimeters.
3
though.
centimeters is like slightly more than an inch.
Yeah, but isn't there a hummingbird the size of a thumb? Yeah, something.
Not the thumbnail. Maybe like the whole thumb.
Yeah.
A couple of inches.
It's like 2
Yeah.
inches, yeah.
Yeah. Also, my last story for the night. Astronomers have taken the Cassini data, pictures that were taken when Cassini went to Saturn and flew by Titan. They have stitched together all of the images of Titan and created the very first surface map for Titan. And this is very exciting because it's given them insight into exactly what the surface is made up of. So whether it's made up of, how much of it is made up of lakes, which there are lakes on Titan, just they're filled with methane, liquid methane instead of water. There are craters, dunes, some areas are hummocky, labyrinthine. They also have flat plains. How much of these various areas are in existence on the surface of Titan, which may be one of our targets. It is one of our targets for future exploration. We're sending a mission there in the 2030s. Nothing going there anytime sooner, but in the meantime, they have this map to be able to delve into the features of the surface. Maybe they'll be able to find a really good landing place. Blair, what do you got?
I have a story about crows.
Okay.
It's more of just a confusing result that I'm throwing out there. A new study found that crows living in large social groups are healthier than crows that have fewer social interactions. We usually assume that this is actually a disadvantage of group living, that the more people or more individuals you live around, the better chances for parasites and diseases to transmit from one individual to another. But this is a specific study where they monitored the behavior of crows and looked at their poop for all sorts of diseases and oocysts. And they found that the ones that lived in social groups were healthier, which means either A, there is something related to social bonds that reduces stress levels, and that reduced stress makes you more healthy and it makes it easier to fight off infection. Or B, that healthier crows are more sociable. They think through this study that they have actually ruled out the latter, that they really think that the fact that they are social is causing them to be healthier and not the other way around. But jury's still out.
Sociality causes health. Maybe that's because maybe they get more infections when they're younger, fight them off, and their immune system's stronger.
Possibly. Yeah. So they were
odd.
looking at poop, but I think they were only looking at they were looking for sources of disease in poop. They should have been looking at stress hormones.
Yeah.
Because if they want to claim that it's all about reduction in stress because you're with your folks, then you would have to be able to identify that sick crows are more stressed and all this kind of stuff. So there more study is needed, but ultimately we know that more social crows are healthier.
Okay.
Which
yeah,
is
well, I mean, if you're
pretty
sick, you're like, leave me alone. I don't want to talk to you. I'm gonna
right,
by
but
myself.
they're claiming that the way that they tested this is showing the opposite. But again, I'm I'm not convinced. The other thing that I'll just throw out there is that the Okinawa Institute of Science and Technology has changed the way that we read research papers by integrating research papers with augmented reality. Now you can flip through their research paper on new species of ants that they found, and a 3D rendering of that ant will pop up in front of you. And you can change the size and the location in your field of view so that you can end up hanging out with an ant the size of a bear in your room. But so it's fun, but it's also, it really allows a new way to interact with data, which is pretty cool.
That is pretty awesome.
Yeah, so even though their source of specimens that they're doing their study on is in Japan, you could get a copy of this research paper anywhere in the world and be able to look at those specimens in a 3D model through your phone or your mobile device. Yeah,
that's really cool.
Yeah,
3D pop. It's like a 3D pop-up book.
Yes,
on your tablet.
Exactly.
Yeah, that's really neat.
Yeah, and
I guess very often when the downside of that kind of a flat 2D paper where you put your pictures or your images in it, the downside is you're looking at it going, okay, there's a picture of an ant, but it's just there in 2D, and you don't get that real perspective of how it really looks, what its features really look like. Yeah,
you might end up with many, many, many pictures from different angles of a thing. But to be able to sort of rotate around as you would any 3D model on a computer and just sort of observe it from different angles and have it be authentically accurate. It also is
and of course the educator in me can't help but think how much more I might have enjoyed textbooks if I had been able to use augmented reality to see things in more than 2 dimensions as I was learning. And this is something that I think we will likely start to see in our education systems. And I think that we could really benefit it. This is something where devices and technology can actually help augment our learning and our understanding. So pretty cool.
Very cool. Yeah. And there's additionally, there are companies that are working on augmented reality glasses. I know that the augmented reality glasses are being developed for gaming systems, but there's no reason that they couldn't also be used for this kind of purpose. Multiple purposes. It's always good. Yeah. Super cool. Justin, let's finish up with some really depressing news.
Okay. Well, if you insist, nitrous oxide. Otherwise known as laughing gas, occasionally used for its anesthetic effects by dentists, although I always assumed that it was to relax people in the lobby of a dentist's office to hear so much laughter. Oh, the drill, it must tickle. They're having a great time in there.
Laughing gas doesn't make you laugh, though.
However, nitrous oxide, N2O, is actually the third most long-lived greenhouse gas behind methane and carbon dioxide. And as we learned from last week's show, 298 times more greenhouse effect causing than CO2, and is one of the main stratospheric ozone depleting substances. And we are releasing more of it into the atmosphere than previously thought, according to new study published this week in Nature Climate Change. We see that N2O emissions have increased considerably during the past 2 decades, but especially from 2009 onwards, says lead scientist Rona L. Thompson from Norwegian Institute of Air Research. Our estimates show that the emission of N2O has increased faster over the last decade than estimated by the Intergovernmental Panel on Climate Change, the IPCC emission report. Increasing use of nitrogen fertilizers, they say, is part of the reason why. So, yeah.
Nitrogen's good. Like it's helped with agriculture, right? Fertilizer, all that stuff. It's good.
Yeah. So this is also sort of it's from the last week's study too. They were finding it naturally being created in the oceans as well, right? So then we have this we have this sort of factor of maybe it's not just this, but maybe the last one from the sort of coastal regions naturally producing N2O means that we may be producing it also from other sources than we initially realized that we were doing. So yeah, it's one of those things. Everything from basically the IPCC reports look to be. The IPCC report, as it was originally published, is now the most optimistic potential outcome of this, as everything that we have had since has only added to the layers of direness. Every comprehensive study thereafter has been finding more contributing factors or more exceedings of limits that were placed on the IPCC report from where we originally started. So this is not good news. However,
it is not good news, but it will help inform future decisions. And if we didn't know about it, we couldn't fix it.
Right.
yes,
Yeah.
but it's not good news. And to that point, really quick, just at the end of the show, there are going to be arguments about it's too late to do anything that are probably going to be adopted by the same groups that were saying there's nothing to worry about.
Mm-hmm.
Right?
Yeah.
It's then going to be too late to do anything about. The other one is going to be, I think, just as sort of freezing of the actions that we need to take, which is people are going to be giving lists of shameful things that you are doing in your small, like you don't have a nonstick toilet yet. Well, then you are causing no.
It's not a you problem, it's an us problem.
Personal individual actions that you take to reduce your carbon footprint are good in intention setting.
Yes.
Paying attention through your intentions. Those are positive, good ways to be in the world. They're not the solution.
Right.
The things that we need to do are basic energy production, basic grid infrastructure. These are large scale issues that we're going to
change our agricultural practices.
They're government, commercial, production,
industrial,
and it's not so much user end as you will be being told and shamed into believing. So
it's not so it's not user end on specific one-off decisions made.
Yes.
But we can, as individuals, make a difference by finding other individuals and working on collective solutions, which is really the different. You think about all the community choice aggregates that exist out there where there are energy companies offering green energy. That wasn't energy companies going, you know what we should do? We should offer green energy. It was communities demanding it. And that is the difference, is that we actually do have amazing power, but we have to work together to leverage that power. That's how the civil rights movement started. That's how the main environmental movement started. And this is a whole new era where we're learning about all these new impacts, but the knowledge is the first step to demanding change.
Yes, but my point is but don't be persuaded into thinking that you don't need a large governmental regulation policy shift change to dramatically change the way very wealthy, influential industries do business, because without that, everything else won't matter. You have to attack there first and foremost, and the rest of the stuff is going to help, but it's not going to change anything without changing how the fossil fuel industry works in the first place. That's the biggest contributor. We can also look at concrete production, those two, and focus on those first and foremost. The rest of it won't matter unless we've done something there. Anyway,
I think we've come to the end of the show.
Mm-hmm.
I think we've done it. Yes,
got to go back into my box again.
Yes, go back in your box. No, we're going to enjoy another week of science. But first, I would love to say thank you to everyone for listening. Thank you to our people who help us out. Thank you to Gord McLeod for helping our chat room run. Thank you to Fada for helping with show notes and social media, making all that happen. It's just amazing that you do that. Identity 4, thank you for recording the show so that we can do the podcast. Really appreciate that. And thank you to our Patreon sponsors. Thank you, Paul Disney, Ed Dyer, Andrew Swanson, Craig Landon, Andy Groh, Ed, Stu Pollock, Philip Shane, Ken Hayes, Harrison Prather, Charlene Henry, Joshua Fury, Steve DeBell, Alex Wilson, Tony Steele, Richard Porter, Mark Masaros, Jack, Matthew Litwin, Jason Roberts, Bill K, Bob Calder, Eric Knapp, Richard, Brian Condren, Dave Neighbor, Taylor P.S., I know that name. Josiah Zahner, that's another one. Howard Tan, Donald Mundis, Sarah Forfar, Dan K, Matt Bass, Darwin Hannon, Patrick Pecoraro, Ben Bignell, Gene Tellier, John Gridley, Corinne Benton, Adam LaJoy, Sarah Chavis, Rodney Lewis, Tiffany Boyd, John Bertram, Mountain Sloth, Seth Agradney, Stephen Alberon, John Ratnaswamy, Dave Friedel, Daryl Myshak, Paul Ronovich, Sue Doster, Dave Wilkinson, Noodles, Kevin Reardon, Ashish Pants, Ulysses Adkins, Artyom, Paul, John McKee, Jason Olds, Brian Carrington, Christopher Dreyer, Lisa Suzuki, Jim Trapeau, Greg Riley, Sean Lamb, Steve Leisman, Kurt Larson, Rudy Garcia, Marjorie, Gary S., Robert Greg Briggs, Brendan Minish, Christopher Rappin, Flying Out, Aaron Luthen, Matt Sutter, Mark Hessenflow, Kevin Parachan, Byron Lee, and E.O. Thank you for listening. Wait, what am I saying? Thank you for your support on TWIS. My brain just broke.
And also listening, as I'm
Thank
sure
you.
they're doing.
Yeah. Thank you for your support on Patreon. Thank you. If you are interested in supporting us on Patreon, you can find information by clicking the Patreon link at twist.org or going to patreon.com/thisweekinscience. On next week's show, we'll be back. Oh, it's TWIS giving season. That's for sure. Time for some science gratitude. Once again, we'll be broadcasting live online at 8 p.m. Pacific time. You can join us, twist.org/live. You can join the chat room there. You can also find us on YouTube, where there's another chat room. Or you can watch on Facebook, but twist.org is a great place to find us.
Yeah, you can also just Google This Week in Science and find podcasts all over the place. If you enjoyed the show, remember to tell your friends about TWIS.
For more information on anything you've heard here today, or for information on how to pre-order the 2020 TWIS Blair's Animal Corner calendar, we can go to www.twist.org. There you'll find show notes, and you can also make comments and start conversations with the hosts or other listeners.
Yes, or you can contact us directly. Email Kirsten at thisweekinscience.com, Justin at twistminion@gmail.com, or Blair at blairbaz@twist.org. Be sure to put TWIS, TWIS, somewhere in the subject line. Otherwise, what will happen to your email?
Your email will be spam filtered into oblivion.
You can also hit us up on the Twitter, where we are at TWIS Science, at Dr. Kiki, at Jacksonfly, and at Blair's Menagerie. We love your feedback. If there's a topic you'd like us to cover or address, a suggestion for an interview, a haiku that comes to you tonight, please let us know.
We'll be back here next week, and we hope you'll join us again for more great science news.
And if you've learned anything from the show, remember,
It's all in your head.
This Week in Science. This Week in Science. This Week in Science. This Week in Science, it's the end of the world. So I'm setting up shop, got my banner unfurled. It says the scientist is in, I'm gonna sell my advice. Show them how to stop the robots with a simple device. I'll reverse global warming with a wave of my hand. And all it'll cost you is a couple of grand. 'Cause this week's science is coming your way. So everybody listen to what I say. I use the scientific method for all that it's worth. And I'll broadcast my opinion all over the earth. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 I've got one disclaimer, and it shouldn't be news, that what I say may not represent your views, but I've done the calculations and I've got a plan. If you listen to the science, you may just yet understand that we're not trying to threaten your philosophy. We're just trying to save the world from jeopardy. This Week in Science is coming your way. So everybody listen to everything we say. And if you use our method instead of rolling a die, we may rid the world of toxoplasma gondii. Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 I've got a laundry list of items I want to address, from stopping global hunger to dredging Loch Ness. I'm trying to promote more rational thought, and I'll try to answer any question you've got. So how can I ever see the changes I seek when I can only set up shop 1 hour a week? This Week in Science is coming your way. You better just listen to what we say, and if you've learned anything from the words that we said, then please just remember it's all in your head. Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 This Week in 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 Science.
And now it's the after show. You got a baby Sadie. What is she eating?
My hair.
Oh. Delicious hair.
Say hi to everybody. Say hello.
I would eat your microphone. Oh, she's so cute. How do you get anything done?
I don't know. In little bits.
I know.
Oh, did you hear that?
Oh my goodness. She's normally asleep right now?
Yes.
Yes.
Well, because I'm normally asleep right now.
Aww.
Every other day of the week, I go to sleep at 9:30.
Yeah. Do you have her in a little Sadie bed, or do you have her cuddle with you?
She is too small. She would fall right off the bed, and that would not be
Oh,
good. So
no.
she is currently sleeping in a pen that I bought that is designed for guinea pigs. In a pet bed next to the bed with many puppy pads inside.
Many puppy pads.
We are still learning to use the puppy pads. Right now, the main problem is that she is so smart. She is such a, I don't know if I've ever met a dog who's smart. She is so smart that she has learned that she can pretend to pee on the puppy pad and she will get a treat. So now she's like squatting onto the puppy pads and we'll look and there's like one little drop of pee and she'll just do it every couple minutes. She's like, oh, here's another puppy pad. Let me just, and then she runs over. She's like, treat?
I get a treat now, right?
That's
I
hilarious.
don't want to discourage you from using the puppy pads because I don't want you to pee on the carpet.
But
I also
you're
don't
a
want
little
you to spend
too
your whole
clever.
life going,
Uh-huh.
It's a little too clever.
Oh my gosh, I
Oh,
can't stop
now she's like
yawning.
looking at you like, oh, do you want a treat?
Seriously, somewhere at the end of the last like 10 minutes of the show, I crashed. My energy level just went
Uh-oh.
crash and burn.
Are we biting fingers now?
Oh, that's not good.
Puppy teeth are so sharp.
Yes.
They're like little needles.
Mm-hmm. Don't
Evolutionarily,
bite, Sadie. Don't
why is
bite.
that? Why? Now she's licking me. Why?
They need to eat things
Yeah, but why are they needles? Why are they little needles?
to hurt their mothers.
To bite the nipples off? Is that what you're saying?
Oh, jeez.
Is that what they're for, little one?
Ed wants to know how big your puppy's gonna get.
She will get to be between 20 and 25 pounds, if that. She's a pretty small puppy, so she might actually be a little less than that. She might be like 18 pounds.
Nice.
Yeah. She's 13, so I guess now 14 weeks. So 3.5 months.
I almost
Her legs aren't going to get much longer. No.
They're not going to get much longer.
I almost completely lost power during the show.
Oh, geez.
Oh, really?
Yeah. So my charging cable has become a loose connection.
Oh.
So even though I'm plugged in, at some point during the show, the connection stopped being there. And so instead of just running off of wall power, it ran through the battery. And I only noticed it at the end of the show that it was down because it turned red. It was down to the 1%. So I jiggled it. But then I wasn't sure that it was going to maintain. So I don't know if I started talking faster during my last story than I was in the beginning of the show. But I had to kind of like ramp up. Like, I got to get to this really quick because I could disappear at any second now, possibly.
That's
girl.
funny.
Good job. You peed on a pee pad. Good job.
Now you get a treat.
I can't reach them. Hold on.
So this kind of reminds me of something one of my older daughter said.
About treats?
Because she was getting presents for potty training.
Good night, Fata.
And it was something to do with, we were looking at, she was looking at a doll, I think in a store. And we're like, well, we're not getting anything this time. So, we're just, because kids, every time you walk into a store that's got toys, they like want to go home with a trophy.
Everything.
I'm like, well, we're not getting, she's like, it's okay. I can just poo on the potty and get it that way. But it was like,
all right.
It was very much like, I know how to get it. I can just order it with the toilet.
I know how to get rewards.
Her first Amazon experience. It's like, if I want something, I can just order it on the toilet. It's fine.
Yeah, there's a lot of child training and pet training that involves rewards and
grown-up training. It never actually ends.
Kids get it.
It never ends.
It never ends.
Reward training. Never.
Yeah, what is it like in college? You do all sorts of things for free pizza. Yeah. Later in life, it might be, that timeshare.
Or the stock option plan, or the benefits that come with the job, or hey, if we hit our quota, there's going to be a office party that we can, or whatever nonsense.
Everybody can have a dress down Friday.
Yeah, this reward system never ends.
Oh, all the conditioning we go through as human beings. Yeah, so Kai has he scored well on a test, and so I was informed by the school district that I can nominate him for the Talented and Gifted program here in the Portland Public School System. And the form to nominate him, I'm supposed to judge him from 1 being he never displays some behavior to 4 being frequently displays some behavior. And a lot of them, it's like, fine. I'm like, I get it. And then it gets into the interesting questions where you're like, what are you looking for here? Like it says nonconformist. And I'm like, what do you want to see here?
Yeah, like my child takes unconventional, unique points of view on things, or does that mean refuses to
to take
be
part
quiet
in
in class when
Yes,
given
yeah.
the request. Like, yeah, it's
what does that mean
yeah.
in school district language?
So vague.
Yeah.
This is the problem. Actually, I've run into this a bunch. Whenever there's surveys of any form, but this most recently there was a work survey that was like this, where the questions aren't anchored in any specificity and are left vague enough that they were interpreted widely and answered widely, therefore, by different people. So some questions, that everybody agrees we're doing really well, and we apparently had rated ourselves very negatively because of the phrasing of the questions.
The questions,
Yeah. So something. It could be something like, do people always follow through with the same thing that they committed to in the beginning? And of course not in science. You always have to change.
You always have to change.
People are always being, the people are flexible that I work with. No, they're not supposed to have been flexible, or you label them as not being flexible. Like, yes, everybody continues. Oh, so you work with unflexible people. No, that's not what I was saying. Unanchored questions and surveys are just so, I don't know, pet peeve.
They're frustrating. Yeah.
I remember I received a review that I missed one of my targets, and so I was rated low on integrity because the person giving this or doing the review thought of integrity as a bolt, where it either integrity of a bolt, it's got a breaking point, and that's when you that's the integrity of a bolt, is when it breaks or it doesn't function. So because I was rated low on integrity in this category of this one goal, but of course I protested and I was like, look, integrity has one meaning when applied to humans. It has nothing. I'm not a bolt.
You're not a bolt.
I'm not a bolt. So I'm challenging this integrity interpretation, because that is so it's people taking surveys, giving them, interpreting them after, all are different if the question is unanchored and left to people's
interpretations. Yeah. Absolutely.
I would love the survey question. Do you interpret this question correctly? Oh, shit.
I don't know. Do I?
I just cursed on you. You have to bleep that.
I don't have to bleep it. It's not in the podcast.
Oh my gosh.
This is
we can curse?
Science after hours.
Oh, we can start cursing and swearing.
We can't curse because then we'll get an explicit rating on YouTube.
Oh.
There's that. Watch your mouth.
Hey, I think I've said this before, but I think this is the death knell of my laptop, because now it won't charge.
Now it won't charge.
Not good.
Yeah.
Down to that.
How are we doing with the Blair fundraiser?
We're getting there. I mean, if we wanted to get half the money from TWIS, I think we're getting there. Okay. We're about there for half.
Yeah, I sent you. There's a couple. Where is she?
And are we halfway to a laptop, or does that make us further along the way to a desktop?
I think it would make us further along the way to a desktop. Kiki, I sent you two.
I know, not based on the desktops you sent me.
The two desktops I sent you are way cheaper than the laptops we were looking at.
Were they?
Yeah. They were $1,200 and $1,700. Which the laptops we were looking at were between $17,000 and $2,000. Mostly.
Oh, right. Okay.
So they're definitely cheaper. And you definitely get more. So I'm interested in that. What are you doing?
I went I should start posting these pictures. I went to an amazing place this week.
Yes.
Tivoli Gardens.
Tivoli Gardens.
Oh, I've heard of Tivoli.
Tivoli here in Denmark is it's like a mini Disneyland, very H.C. Andersen sort of inspired. It's already Christmas there. I just missed the Halloween.
It's already Christmas I feel like.
already Christmas, but there's rides and pirate ships and because this is of course Denmark, there's also plenty of places to get like hot toddies.
I love hot toddies. That'd
as
be
you
yummy.
go around the grounds of the gardens. But yeah, fantastic, amazing thing that was created in the late 1800s, I believe, by a newspaper magnate who, in the center of Copenhagen, created this little wonderland for people to go and wander about and explore.
That sounds fun.
Yeah, it's really fun, really beautiful. Magical little spot here in Denmark. Yeah.
That's cool. Yeah. With hot toddies. Is it cold there?
Not really. It's very much like San Francisco weather, I would say.
Oh, interesting.
Because there's a constant marine inversion layer kind of a thing going on. It's a coastal place, so the temperature ranges aren't really that wild. There's a lot of cloud cover and a lot of drizzle, but it hasn't been freezing cold, and it doesn't get very warm either. It's in that sort of in between.
Yeah.
I have experienced Denmark in winter where there is snow on the ground and it's really, really cold, but apparently global warming has been affecting that. Some talk
probably a bit. Yeah.
Winters haven't been as cold. But of course, that could change. One of the things that might happen is if that Atlantic conveyor belt slows down, you could see, for a while, some extreme cold, sort of polar cold, drop down a bit. So time will tell. But it's also the sea level rise even though this is an island, sealand, where the bulk of the population in Denmark lives. Sea level expectations over this next 100 years are not expected to be nearly as dramatic as they are in other parts of the world. One of the weird things about it, too, is that the glaciers on top of Greenland and through a lot of Scandinavia, as the ice melts, it relieves pressure on the soil. And the soil expands. It actually might rise in elevation a bit for portions of this area of the northern hemisphere, so that will sort of offset some of the sea level rise.
Yeah, it depends. Like there are the different areas where some areas the groundwater is being extracted too fast, and so there's the subsidence.
That's San Francisco. San Francisco is subsiding quickly.
Yeah, and then other places where, we're fine and we're going to get springy. Yeah. Springy-ish.
So a lot of the northern regions will sort of be springing up because of all the weight of glaciers being lifted from the ground will actually rise the elevation of those places, which is pretty interesting. And of course, what this means is the distribution of sea level rise will fall largely on the places that did not contribute to it in the first place.
Yep.
Except for Florida. Florida will get what's coming.
Totally in on it. Yeah.
One of the few places.
Oh my goodness. What? Is your dog eating the cords?
She was laying on top of them. Like, what the hell?
Is it that time?
I'm tired. I got really tired. I have a child lying on the floor sleeping next to me.
In that case,
nice.
Say goodnight, Blair.
Good night, Blair. Say goodnight, Justin.
I can't.
Say good morning, Justin.
Good morning, Justin.
Good
night, Kiki.
Good night. Good night, everyone. Thank you for watching. I hope we'll see you again next week. We hope you have a wonderful week and full of science. And I'm going to try and get the rest and be energetic next week. And I'm going to hit a button right now. Good science to you all. Oh gosh, I had to hit another button.